So this is a system of inequalities, right? How do you tell the difference between a system of equations and a system of inequalities? Yeah, that seems like a silly question, right? Okay, but it's the symbols right here. If you see the equal sign, that's a system of equations. If you see inequality signs, that's a system of inequalities, okay? In a system of equations, what type of solution are we looking for? 1 point, right? A system of equations, we're looking for 1 point. What about a system of inequalities? What are we looking for? Like an area that makes them all true, right? So how many solutions are there to a system of inequalities? Like an infinite amount, right? Could there be no solutions? Yes, right? But it's either no solutions or infinitely many solutions. We're not going to have a point, typically, I guess I should say. Okay? I guess it is possible. We don't need to talk about that right now. You okay? So the first thing I'm going to ask you to do is I'm going to give you a system of equations like this, and then I'm going to give you a point, like 2, 5. And I'm going to say, is this solution, excuse me, yes, is this a solution to this system? Well, how do we figure that out? So you guys are using the right word, substitute, plug it in, but you know what to do, right? I'm going to take this point, x and y, and I'm going to plug it into each one of these equations, right? Each one every time? Maybe not, right? Maybe not. Okay, let's try this one. 5 is less than or equal to negative 2 plus 3. 5 is less than or equal to 1. 5 is less than or equal to 1? That is not true. That's a no. So do I even have to plug it into this one and this one? If I already know it's not true for this one, then the answer is just no. Because the question is this a solution to this system? No. Here's my work, right? This is my work proving that I know that the answer is no. Does that make sense? Okay. What about this system? 2x plus y is greater than or equal to negative 3. 2x plus y is less than 5. 3x minus y is greater than negative 4. And 3x minus y is less than or equal to 3. Now, do you think people freak out more at this system than this one? Yeah, because why? There's 4. Do we freak out? No. I mean, I know you do sometimes, but let's not today. Okay? So remember what you're also given as a point. And you're being asked, is this point a solution to this system? So how do I figure that out? Substitute it in. 2 times 1 plus 3 is greater than or equal to negative 3. Well, 2 times 1 is 2. 2 plus 3 is 5 is greater than or equal to negative 3. Yes. So my answer is yes. Well, that's what we did last problem. We tried the first one and wrote down what it was. Because this point has to be true for all of them for the answer to be yes, right? Okay, so go to the next one. 2 times 1 plus 3 is less than 5. Well, 2 times 1 is 2. 2 plus 3 is 5 is less than 5. 5 is not less than 5. So the answer is no. Once I get a no as my answer, I know the answer to the question, is this point a solution? No. Okay? But if I get a yes, I have to keep going until they're all yeses, right? Does that make sense? Okay, let's try one more then, please. X minus y is greater than or equal to 6. 2x minus y is less than or equal to 12. Y is less than or equal to x. And y is less than or equal to negative x minus 1. So that's my system. My question is this point, 3, negative 4, a solution to this system? So 3 minus negative 4 is greater than or equal to 6. 7 is greater than or equal to 6. That is true, so that one's a yes. Can I just put yes? No? Okay, good job. 2 times 3 minus a negative 4 is less than or equal to 12. 2 times 3 is 6. 6 plus 4, so 10 is less than or equal to 12? Yes. So can I just put yes? Oh, keep going. Okay, all right. Negative 4 is less than or equal to 3. Yes. Surely they're all yes if we've gotten all the way this far. Can't I just put yes? No, not without proof, right? Negative 4 is less than or equal to negative 3 minus 1. Negative 4 is less than or equal to negative 4. Yes. Okay, guys, I'm not asking you to choose. Do you understand that? I'm not saying is negative 4 less than or equal to negative 4 and you have to say equal to. I'm saying is negative 4 less than or equal to negative 4? It's a yes or no question, right? Does everybody understand that? Okay. Okay, now what? Oh, now it's yes, right? Because I took the point and substituted into each one of the restrictions, each one of the systems in my system of inequalities, and every single time it was yes, so then my answer is yes. Does that make sense? Okay, do you have any questions about that? Would you please take out your piece of graph paper that I gave you? Okay. Now, if you're a visual learner, I'm going to give you a heads up right now. If you're a visual learner, you might want different colors for this part of the lesson. Okay. Those of you that like that know who you are. If you don't care, that's totally fine. Okay. I'm going to be using different colors up here just so you know. Okay. Here's the system. Okay. Now, the directions this time are graph the system. The directions could be solve the system. But if it's a system of inequalities, how do I solve that system? By graphing, right? I have to graph to find the shaded area. Because keep in mind, anytime we solve an equation, we get one answer or two answers, something like that. But when we're solving a system of inequalities, when I solve any inequality, I get a shaded area. Remember we had a number line and we had to shade one way or the other? Remember doing that earlier this year? This time though, because I have two variables, I have two number lines. I have a coordinate plane. Okay, now the problem with this that I noticed on your last test is that some of you do not remember how to graph by hand. Okay, and we are not doing this in the calculator. We're not. Okay, I need you to know how to do this by hand. I need you to know how to find the shaded area by hand. Is everybody clear on that? Okay, so let's graph the first one. I'm going to graph the first one in purple. Okay, how do I graph the line y equals 1? It's a line. If it's a line, and it only has one variable, it's telling you which axis it's crossing and where. Okay? Which axis it's crossing and where. Which axis is this crossing? The y. Where is it crossing the y? So is it going this way or is it going this way? Guys, which one is the y-axis? This one. If it's crossing the y-axis, it has to cross at 1. So it is a horizontal line. Does that make sense? Okay, now before I graph this, I need to come over here to the side and have a little commercial break because you'll notice that there are different kinds of inequalities, right? So as a reminder, if I have a less than or equal or greater than or equal in my equation, what kind of line do I draw? Very good, it is a solid line. And if I just have a less than or a greater than, what type of line do I draw? A dash or a dotted line, right? Do you remember that? Now, what kind of line am I drawing for this inequality right here? It is a solid line, and we said a minute ago it's crossing the y-axis at 1. So it's right there. Now, I said we were going to shade, right? We're actually not going to shade till the very, very end. Okay? We're not going to shade until the very end because if I start shading now, things are going to get really confusing. Okay? But I don't want to have to wait to tell myself where to shade because that's just going back and doing a lot of extra work. So right now, after I graph this line, I want to tell myself where to shade. Where is the y values greater than or equal to 1? Oh, so above the line? So what I'm going to do is I'm going to tell myself that I would shade above the line if it was time to shade. Okay? How am I going to know when it's time to shade? I've graphed all the lines, right? Then I'll know that it's time to shade. All right, I'm going to graph the second line in red. Okay? How do I graph this line? So I go up 6. It's telling me which axis it's crossing and where. So 1, 2, 3, 4, 5, 6. It's crossing there. And since there's only one variable, it's either a horizontal line or a vertical line, it's crossing the y-axis, so it's a horizontal line. And since it's less than, I would shade below. Okay? Like somebody pointed out, I don't know who it was, we made sure to draw a solid line because it is less than or equal to. Okay? Now, for the most part, you guys were okay with those. It was lines like this that you struggled with. So I'm going to do a real super quick refresher. Okay? First of all, it's going to be dotted. Definitely going to be dotted, right? Okay? But this is the y-intercept. That's where I start. I go down 1, 2, 3, 4, 5. When I go down 5, I start from this dot and plot the slope, which is 2 over 1. So I rise 2 and run 1. Rise 2, run right 1. Rise 2, run right 1. Well, that's part of the reason why I'm reminding you, right? I could fall 2 and run backwards 1 if I want. But now I have the whole entire line there, don't I? Okay. Don't you just actually need 2 points to make the line? Yes, technically yes, but I would like to see all of them. It's way easier to see the line. Now when I draw it, I want to make sure that it is not a solid line and that it's obviously not a solid line. Okay? Now, where is this line less than? Is the line less than above it or below it? Below it. Now that I have all the lines drawn and I've told myself where to shade for all the lines, now I shade. Where am I shading for this particular problem? Where all the arrows are pointing. Okay? Now, I love you guys, but please don't get too OCD on me here. Okay? Just shade it in and go on. We don't have to make sure every little part is shaded. We're okay. Okay? Now, I need to check your understanding. I need 3 possible solutions. How many solutions are there? An infinite amount, right? I need 3 possible solutions. Would somebody give me one possible solution? 2, 6 is right here. Is that a possible solution? How do I know it's not a possible solution? It's not in the shaded area, right? 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Is that in the shaded area? Then 5, 3 is a possible solution. 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Is that in the shaded area? Then 8, 5 is a possible solution. I would like to trick you now. Are you ready? I'm going to try to trick you. Okay? What about 56? 50, comma 6. Can I graph that on here? No. But where does it lie? Where does the point lie? Isn't it on the red line? Are you sure that's a solution? Good, I wanted you to be. 50, comma 6 is a solution. I can't see it, but I know it's going to be part of the solution, right? Because as long as it lies on the solid lines, isn't that part of the solution? Okay. Then what about, I know we already have 3, but let me ask one more, okay? What about 3, 2? 1, 2, 3, 1, 2. What about that point right there? Why is that not part of the solution? It's on the dotted line. Points on the solid lines are possible solutions. Points on the dotted lines are not. Okay? Any questions about that? You good? Okay. Ready for the next example? X minus 4y is greater than 0. X plus y is less than or equal to 1. And x plus 3y is greater than negative 1. So before we can do anything of graphing with this, what do I need to do? Before I can graph them, what do I need to do? I need to get y isolated, right? Okay, I need to get y isolated so that I can find the slope and intercept. Okay, it's not necessarily slope-intercept form at this point because these are inequalities, not equations. Okay, but I could even write them like out of order as long as I know what I'm doing. Okay, so for this first equation, what am I going to do first? So I need to subtract x from both sides. No, not there. Weirdo. Negative 4y is greater than negative x. So how do I solve for y? Divide by negative 4. Uh-oh, uh-oh. Danger, danger, danger. Y is less than. Guys, it's not ever going to be less than or greater than. It's less than or equal or greater than or equal, not never less than or greater than. Okay? Y is less than 1/4 x. Let's go ahead and plot that. Let's go ahead and graph that. Okay? What's the y-intercept of this? So my y-intercept is at 0, so it's a dot right at the origin. And then what's my slope? So I rise 1, run 4. Rise 1, run 4. Or fall 1, run backwards 4. And then I have my line. What kind of a line am I drawing here? Okay, please make sure we're letting everybody have a chance to think before we shout out the answer. Okay, everybody gets a turn, not just one person. But I have my dotted line, right? Now, it's less than, so is less than above the line or below the line? It's less than. Is less than above the line or below the line? That took a terrifyingly long time. I still love you. But less than is below the line. Okay? So that's my first equation done, right? What about my second equation? So subtract x from both sides. Y is less than or equal to negative x plus 1. Oh, that's a lot nicer, isn't it? My y-intercept is what? 1. From my y-intercept, what's my slope? Guys, please remember, one person doesn't need to be answering. Okay? I go up 1. From my 1, what's my slope? So I go down 1, right 1. Down 1, right 1, because my slope is negative, so I need to make sure that my line has a negative slope, falling to the right. Okay? I could go up 1 as long as I go left 1 to keep my negative slope going on, right? What kind of a line am I drawing here? Solid. Okay. And for this line, am I shading above or below? It's less than or equal to, so I'm shading below. Now, did I even really need to put this arrow right here? I really didn't, right? Because I already know it has to be below that first line that I drew. So really all I care about is down here, right? Okay. What about the last one? Subtract x from both sides. 3y is greater than negative x minus 1. Dividing everything by 3, I get y is greater than negative 1/3 x minus 1/3. Ugh. Do I freak out when there's fractions? No, I do not. I go down 1/3, which is ish right there. I fall 1, run 3. Fall 1, run 3. Fall 1, run 3. And so on. Or from here I rise 1 and run backwards 3, right? Solid or dotted? Solid or dotted? Dotted. And greater than? Above. Where's my solution? This tiny triangle right there. What a mess. But it's right, isn't it? Yeah. Isn't there sometimes in our life, isn't there messes? But we still go on, right? Any questions?